This is, believe it or not, a Monarch lathe. This is what they call a Monarch Merit lathe. This is the lightest duty lathe that Monarch made. They made this in an attempt to compete in the lighter lathe market. Now, I bought this as a non-runner. It's got a DC drive in it that's known not to be working. I got this for such a low price, basically scrap prices if you include everything else, maybe even less than that. It makes it viable to repair this. My plans are, instead of repairing the existing DC drive, which is full of 50-year-old plus components, I'm going to gut this, put a AC drive in here with a 3-phase motor. I'm not a licensed electrician or nothing, so I won't go through every exact detail about building the panel. I will let you know that all the fuses, everything will be sized properly. I'll document the rebuild process. Might not be what everybody agrees to. Some guys, they might prefer to repair the DC drive for one reason or another, but I'm going to go with the AC drive. And another thing I'll do is I'm going to go through and clean this up some. You'll obviously see we got missing handles. I replaced missing handles, wrong handles. Eventually, I'd like to get a 4-jaw chuck for this. I haven't cleaned up anything else. I haven't cleaned up any of the ways here. I haven't cleaned up the cross slides or none of that stuff. The top slide it from one end to the other. Clean all the dirt and grit from sitting 10 years out from underneath there before I start dragging it back and forth and rubbing all that grit in all the ways. I will be pulling this top off, which I imagine will give me access to the gearbox to do a little more thorough investigations. I've got to pull that off and find out what kind of variable resistor or whatever's behind there, and see if I can either utilize that as is or if I've got to replace it for the input to the VFD to vary the drive. My goal is when you approach the lathe, it won't look any different. In fact, it'll run the same. You'll still get the same speed variation on this dial. It'll all function the same. It's just all the electrical inside will be updated, more modern. I'll still use these same buttons for turning on and off the power to the frequency drive. And it all should work out pretty good if it goes as planned. If I don't show everything in detail, I'll at least make summary videos as I go along and document the work on a little known of machine. And if somebody doesn't find the information useful, hopefully they'll at least find it interesting to watch the process. Here's the existing servo motor. I've kind of flipped it out of the base there. I'm going to pull it out on the motor plate so I can put it up at least on my workbench and get an idea where it's positioned at. Because I'm probably going to have to make a adapter for the new AC motor to get the pulley in the same location. So this is quite heavy, so I'll have to get the cherry picker over here. I'll pick this up and do that. So I've also looked around some other areas. Here's the forward and reverse switch, just a industrial selector switch on the end of the main shaft, which turns the machine on and off. So that's kind of interesting setup. At least I'll be able to replace it easily if it ever needs to be changed. And I've also opened up this gearbox. So there you can see the potentiometer in there, used to change the speed. I got to figure out what value that is. But even if that doesn't work, that's a pretty standard potentiometer, so I could swap that out to the correct value if I need to run the VFD. All the gears and everything in the back look real good. Hardly any wear on them at all. So at least it seems to have been maintained as far as keeping oil in the this gearbox. I mentioned before it was on the low side, but it is visible in there, so it's not empty by any means. Pulled the electrical panel out of the base. It's quite dirty in there. You'll have to clean that up. There's the some of the leads from the forward reverse switch, the potentiometer up top, and the power leads for the servo. Power leads for the servo will be going away, but I'll probably be using most of those other wires. Over here on the bench with all the mess, here is the electrical panel out of that machine with this DC drive. Now, a little bit of information I found. I guess this DC drive was the one of the weak links of these machines, so we'll be replacing that. Some of the parts here that are going to go in to replace it. I got the drive in and reactor and other box of parts, relays, cooling fans, and all sorts of stuff, fuses. So I'm going to strip this panel down, start laying out the parts, deciding exactly how I want to position everything before I bolt it down and start wiring it. I might end up putting the VFD on the left hand side. As you see, there's an existing hole in the base. I might expand that out and put a grill with some sort of mesh on it to keep the large particles of dirt out of there, because the VFD is going to need some air to keep cool, so I could put the VFD on the back plate above that and then draw some air through the front panel. Perhaps maybe I'll mount a cooling fan somewhere here on this panel to draw air through there and keep that VFD cool. VFD does have a small fan of its own, but they do recommend ventilating it further. So after I strip the panel down, I went real quick with the MIG welder, closed up all the original holes and gave it a real quickie paint job on there. It's not perfect by a long shot, but I've gone through many different layouts on here. I think I'm getting close to my final layout here. You see, I've decided to move the VFD to the right hand side. I'll explain that over here in the base of the machine. So as I was originally planning on putting the VFD on the left hand side where that hole was in the base already. But when I was cleaning it out, I found that left hand side was the dirtiest side of the base. That's where the cables and stuff come in there. Wanted to minimize the dirt and stuff coming into the VFD, so see, I've got a small piece of aluminum angle over there. I'm going to make a little patch cover over that, cover up that existing hole in the bottom. I made a new hole on the right hand side where I'm going to put that grill on there, and maybe even a little piece of foam filter material underneath it, so the VFD will be on the right hand side there, and it'll have a way to keep cool. So over on the motor side, got the DC servo pulled out, getting ready to put the AC motor in there. The AC motor, it's about 3/4 of an inch shorter from the bottom of the base plate to the center of the shaft than the DC servo was. So the AC motor, I'm going to shim it up a little bit, and it's going to have to be shifted to be your right in this picture here. I've got some scrap that I've saved, a couple pieces of that. I'll make some straps to adapt that AC motor in place of the DC servo. Other than the different mounting, the good thing is the shafts are the same size, so I can just swap the pulley from one motor to the other. Okay, excuse the big mess around here in the middle of this project. Give you an update. See, I've got the motor, the new motor installed there, wired in. Not quite done with it. But here is the rebuilt electrical panel. See, it's quite a difference from the old one. Now I have powered this up, check rotation, tune the motor. I still need to go through and set all my parameters, get it running off the external controls. But it does run off the internal controls here. So you're set at 34 hertz there. Good. A little bit of a noise there. I don't have the carrier frequency set too high. I got it set at about 8 kilohertz. I can go up to 10 before I got to derate it. I'm going to bump it up. I don't know. We'll see. See, it runs all the way down to 20. Without too much noise. So I might let it go there. Let's see. It's 90 hertz, so 150% of normal speed. Seems to run pretty good. Of course, I'll set the acceleration and deceleration and all that once I get everything hooked up. But it runs anyways. So now I've got to get all the parameters set up to run off the external forward and reverse switch and the speed potentiometer. But hopefully, if everything's hooked up right, that'll just be a matter of changing some parameters in this controller. We'll get the belts hooked up, get the pulley on the motor, give it a shot, and bring you back. So I've got it all together, all closed up. I've gone and cleaned up the major mess on it. We can still use some more cleaning. Everything functions pretty well. Only issue I have is these speeds don't precisely match what I'm getting out of the spindle. Appears this is a logarithmic scale instead of a linear scale. I tried putting a log taper or an audio tapered potentiometer in there, and I couldn't get it to work right, so I put a linear one in there. I've got it pretty accurate. I've got it accurate on the low speed and the high speed. So I might have to go back and make some labels for the speeds in the middle. No big deal. Bought some knobs off McMaster Car. Made some shafts out of some 3/8 round stock. So this is new. All three of them controls are new, replaced, cleaned up. Got all the grit out of the ways, top slide, cross slide. Those are original levers there. Got it all together. It looks pretty much stock except for this cooling fan on the front cover, which I added to keep the frequency drive cool. All in all, it seems to be in good shape. So I got this is all cleaned up. More cleaning to do, a little bit more cleaning to do. It's been repainted once, just kind of an overall spray. You can see spots where they didn't get painted, like behind the carriage here, but it's nice and smooth. Lead screws in good condition. The feed shaft is in good condition. So I think overall this is a pretty good lathe. I've got lots of clean oil worked in it. I'll probably work a little more clean oil into it as I go. Let's give it a run. So you can hear the cooling fan that I added there. Set all these knobs are new here. I oiled this chuck, so hopefully I don't get too much oil spatter out of it. Low speed. High speed for loading here, that's 370 RPM. See, I've tuned the accelerations and deaccelerations some. I stayed pretty conservative on them. Eventually I want to get a larger chuck on here, and then I'll tune them a little more aggressive. Got a high here. It's about 420 RPM the high here. It's got a lot longer decel time than acceleration time. Maybe I'll play with those as we go. But all in all, it seems to work. Seems to work fairly well. Lead screws running, so that neutral. Overall, I'm pretty happy with it. I'll put in feed here. All the feeds work. Cross feed works. Longitudinal feed works. It'll work pretty good. Well, that's it. I hope you enjoyed this short video series and getting this lathe ready to run and get ready to do some projects on here. See you around next time. Thanks for watching.